Now for this question then, we're given that a random sample of 50 salmon was caught by a scientist, and he recorded the length L centimetres and the weight W kilograms of each salmon. And we're given the following summary statistics. They were calculated from the data, and we got them here. Okay, the sum of L squared, sum of W, sum of LW, and we're also given SWW. And what we've got to do then is find SLL and SLW. Now to do something like this, normally what we're given is X and Y data, and we should be familiar with the formula that SXY is equal to sigma XY minus sigma X multiplied by sigma Y, all divided by the number of values n in your sample. This is a very common formula. So you normally find this in your formula book anyway, but what we need to do here is just adapt it for us here. Okay, so when it comes to working out SLL, all we're doing is replacing the X with an L and the Y with an L. So we're going to have sigma LL, sigma L squared for instance there. So that's going to be sigma L squared, and then minus, and here it would be sigma L multiplied by another sigma L. So in other words, that's going to be sigma L all squared over, and then it'll just be n, the number in the sample. So we just now fill in our values. So we can see that sigma L squared is up here, 32754.5, and then we've got minus sigma L all squared, that's 4027, and that's all squared and divided by n being 50. And if you work this out, what you end up with is exactly 3419.92. Okay, so SLL. We've also got to work out SLW. So to work out SLW, we'll just come down here. Then SLW is going to equal, well, we're replacing the X with an L and the Y with a W. So it's going to be sigma LW minus sigma L times sigma W, sigma L times sigma W, all over n. And again, we can just take our values from up here, and we've got sigma LW as being 29330.5, then minus sigma L, which is 4027, and then we multiply that by sigma W, which is 357.1, and divide that by 50. And what we find we get for that one is exactly 569.666. Okay.